Alright, so from this lecture forward, we are going to learn how to solve system of differential equations. But that is same as finding the eigenvalues and eigenvectors of the coefficient matrix A of your system of differential equations, okay? So that involves quite a bit of linear algebra. So in this video, I'm going to cover how to find eigenvalues and eigenvectors in very basic, simple manner. But really, you should take your linear algebra notes back and go online and recall your linear algebra knowledge, okay? Otherwise, it's going to be a pretty long semester until the end, okay? Alright, so let's continue. So what is an eigenvalue means? So let's touch it in a very basic, simple manner. Now let's say you have a matrix A and a vector K. Now let's draw a vector K randomly. So let's say this is K. A vector has a magnitude and a direction, okay? Now eigenvalue means, let's say you multiply this vector by a matrix A. Now when you multiply by a matrix A, that transforms the vector into something else, could be something else, okay? So that's really what happens when you multiply by a matrix is it happens a transformation. And what you would expect is, you would expect this vector to change, right? Vector K to change. But let's say when you multiply by this matrix A, the only thing that happens is that you either stretch this vector K without changing the direction, okay? Let's call it, then the vector will be like a lambda times K, a constant times K, right? If the initial vector is K, the new stretch vector could be 2K. Or you either shrink the original vector K. In that case, lambda is less than 1, right? So when you multiply this vector K by a matrix, if the only thing that happens either a shrink or a stretch of this vector, then it have to be a special transformation, right? It didn't change the direction of the vector at all. So these type of vectors and these factor that shrink or stretch is called eigenvalue. So this lambda is an eigenvalue. The vector K that didn't change is actually an eigenvector. Now one thing to notice, you just cannot say an eigenvalue and eigenvector, okay? It have to associate with a matrix. Here in this case, lambda and K are eigenvalues and eigenvectors of matrix A, okay? The reason is, this does not happen for any random vector, okay? So it happens for so specific vectors of special type of vectors from matrix A. It's like a qualitative property of matrix A. It's not like that you can take matrix A and you can take any vector in the world. When you multiply any vector in the world by A, you just shrink or stretch. No. Okay, there are only special set of vectors that can do, which we call eigenvectors, but they are directly connected with A. It's like a qualitative property of A, okay? That's what I'm trying to say. Alright, now that's a very, very brief overview of what is eigenvalue and what is an eigenvector. You should have learned more from linear algebra. Alright, now how to find these eigenvalues and eigenvectors? That is what important now. Okay, so we know when you multiply vector K by A, you should get lambda times K. It should just shrink or stretch the vector. Now what I can do is, I can take this lambda K to the left and take out a K. So we get A minus, A is a matrix, so lambda is a scalar, a number. So when you take out lambda times I, where I is the identity matrix, okay? So you get this system of equations. Now you want to find lambda. What we do is, well, K and lambda K are linearly dependent two vectors, because this is a vector K, this is a constant multiple of vector K, right? Any constant multiple of another vector is these two make a linearly dependent set, right? So that means determinant of A minus lambda I should be equal to 0. So we use this fact to find our lambda, okay? All right, so let me do an example and it will make more sense, okay? All right, so let's take this matrix A 2, -4, -1, -1. Now you want to find the associated eigenvalues and eigenvectors. What you do is, first write, I will do it step by step. Here are the steps that you should follow. First write A minus lambda I matrix. Okay, so A minus, so A here is, let's write it, 2, -4, -1, -1, minus lambda times I. I is the identity matrix. Okay, so identity matrix means here this is a 2 by 2 matrix, 2 columns and 2 rows. So your identity matrix is 1, 0, 0, 1. I think you should know this from linear algebra. So when you multiply by lambda, really what you have here is minus 1 times lambda is lambda, 0, 0, lambda. Really what you have is this. This is A minus lambda I. Now writing A minus lambda I means try to simplify this. Try to write it as a one matrix. So subtract element wise element. Okay, 2 minus lambda, -4 minus 0 is -4, -1, -1 minus lambda. So this is the A minus lambda I matrix. So that is what you should first find. Okay, A minus lambda times the identity matrix. Try to rewrite it as a one matrix, just like here. Now what you want to do is you use the fact that determinant of this A minus lambda I should be 0. So what you have to do is you have to find the determinant of this matrix. So let's find. So determinant of a 2 by 2 matrix. So you first multiply these two. 2 minus lambda, -1 minus lambda. Subtract multiplication of these two. -4 times -1 is 4. So this is equal to 0. Alright, so now the next step is to simplify this expression. Okay, so let's expand the bracket. So that is what you always have to do. Expand the bracket, simplify, get a polynomial. You should always get an polynomial. Okay, we do have a special name for this polynomial, which we'll get into that later. So let's expand. 2 times -1, -2, 2 times negative lambda, -2 lambda, this time this plus lambda, plus lambda square minus 4 is equal to 0. So let's rewrite this. Lambda square, -2 lambda plus lambda, negative lambda, -2 minus 4 is -6. So this is the simplified polynomial we get. This is a polynomial of lambda. So once you always find this determinant of A minus lambda I, you will always get a polynomial of lambda, which we call the characteristic polynomial. Okay, so we call it the characteristic polynomial. Now once you find this polynomial, you are one step away from finding the eigenvalue. So what you need to do is find the roots of the polynomial. Okay, so you can use the quadratic formula. If it is a second degree polynomial, you can factorize any way you have learned in your classes. Okay, all right, so let me factorize this. This will be like lambda minus 3 lambda plus 2, right? Let's double check. Yes. So what are the eigenvalues? So eigenvalues are the lambda values that satisfy this equation. So lambda minus 3 have to be 0, or lambda plus 2 have to be 0 if you want 0 on the right hand side. So either lambda is 3 or either lambda is -2. Okay, don't write lambda is -3 and +2. It's not. Okay, it's just here lambda can be 3, here lambda can be -2. So we have two eigenvalues, so let's call them first eigenvalue lambda 1, second eigenvalue lambda 2. These are the two eigenvalues. Okay, so that is how you find the eigenvalues. This is a 2 by 2 matrix example. Okay, so let's rewrite the steps. Okay, first write A minus lambda I matrix. Okay, then simplify A minus lambda I matrix, get a one matrix. Okay, then find the determinant of this matrix. It could be a 2 by 2 matrix or 3 by 3 matrix. I don't think we will go more than 3 by 3 in this course. Okay, so this determinant, simplify the determinant. You should always get a polynomial of lambda. Okay, so polynomial of lambda, polynomial of lambda. Now what you need to do is factorize, use the quadratic formula, whatever method you like, and find the lambda values that satisfy the equation or the roots of the polynomial, and those are your eigenvalues. Okay, all right, so let's develop the eigenvalue discussion furthermore in the next video. Okay, all right, thank you, bye bye.